Yo, what's going on, guys? Welcome back. Today we are continuing the SOC level 1 path for the new path, right? The SAL1 professional cert path that they're calling it. They updated it. They made it better, supposedly. So far, we're only 3 boxes in, but we're going to do every box in it. We're going through them. I'm trying to knock them out quickly. I'm trying to do a couple a week. I'm trying to make them go even faster if I can. But right now we're doing systems as attack vectors. This is the 4th one. So hopefully this helps you guys, and hopefully you guys learn something. Before we get started, guys, please hit the subscribe button, hit the like button. It helps out tremendously. It's the only way I can keep doing the content, only because at this point the videos have gotten to, or the view count, and videos and stuff like that have gotten to a point where in order for me to give you guys better content, like review products and things like that, right, there's costs associated with all of that. So I've been trying to give you guys more content that shows that, and also give you guys content where I'm actually investing back into the videos a lot more, and all that stuff. So hopefully this helps you guys. Hopefully you guys learn something, and let's get started. So very first thing, we covered the humans as attack vector, right? Everyone knows humans are the problem. The thing I don't like about the way they formatted this as systems as the attack vector is they say in here, like, can systems be basically... there's some question in here that is like, can systems be taken advantage of without human interaction? The answer is yes, but the reality is, who creates these systems? Humans. So at the end of the day, the human is always the issue, right? That they need to make that very clear. That, and they talk about misconfigurations, which we'll talk about, but that's one thing. Yes, systems and humans are different attack vectors in the cyber world. But at the end of the day, it's all comes back to a human at some point, right? A human designed the system, a human configured it, a human set it up, a human did this. So that's how it's getting flaws, right? The system is doing exactly what it's told. So understand that there are flaws in systems, but it all comes back to who made that system. So let's go ahead and get into it. So the definition of a system, right? This is their example. Imagine a castle, but now with a trained gatekeeper. So you've got the people trained. So now people can't trick the person to get in, right? They know how to identify phishing and deep fakes and all that. However, if the lock on the main gate is fragile, I didn't mean to click that. I don't even know what that is. All right, never actually used their AI. So, but if the lock's cheap, right, you just go and cut the lock and you go right in. Pretty simple, right? Same thing. One person commented yesterday on one of my videos and said, like, that I talked about the human getting past the firewall, right? And what I said was, firewalls realistically aren't able to get past if you don't have a vulnerability, right? Well, that's true, but the reality is, if it's a poorly configured firewall, or if it's not updated or whatever, then yes, you can bypass the firewall doing that. Which, again, you're going to go for the human first, right? That's the easiest. Then, if there's vulnerabilities out there, well, that means you're not fixing your stuff. Super simple to get in. So what is a system, though, right? We talked about firewall. We talked about, in this case, they're talking about gates. They're talking about here, these are all different systems, right? A laptop of a school student, a laptop of a bank senior IT admin, mail server, so an actual mail server at the heart of an industrial network, and a government website management panel. A system is basically anything you want it to be, right? In IT. What I mean by that is, it could be your firewall, that could be a system it could be a computer, it could be a phone, it can be a server, it can be whatever piece of equipment that is being compromised. A VM is a piece of equipment. It's hosted somewhere, right? So understand that a system, it can mean a lot of context here, because you could say our entire enterprise system, whatever design you built, is compromised, or you could say the mail server's compromised. Those are both still systems. So understand that it can mean a lot of things in a lot of contexts, but realistically, it's just whatever you're talking about, the actual hardware and the actual software that you're talking about, the actual system, if you will, that you're working on, discussing, all that in a cyber event. That's what the system is. So, can cyber attacks happen without victim intervention? Yes, there are cyber attacks that happen, especially with AI. I can't stress this enough. AI is showing that it is just a breeding ground for attackers to spread, because it's so easy. There's no interaction. There's no human interaction. Before, I had to trick a user to click something, get to do this. AI just does everything for us, so it's super easy to get it to do stuff. So AI is making this even easier, but it's very easy to I say very easy. If there's a vulnerability in a system, I don't need the person, right? I can just take advantage of that vulnerability and get in. That's what they're talking about here. It doesn't need a human on the other side to interact with me. I don't need to send you a link. I don't need you to click something. I just take advantage of that. One thing that we're going to discuss here is that I see all the time is people that are new to cyber, they don't understand the difference between external and internal assets. And what I mean by that is external is the things like you go to showdan.io or you go do an in-map scan on a company's website or whatever. Those are all external facing. What they don't see is behind those firewalls, behind all that external facing, think about your home internet, right? If you gave me your IP right now to your home internet and I ran a scan on it, I'm only going to be scanning that router, right? I'm not going to be scanning anything else. Think about inside your home. How many devices do you have? 10, 15, 20, 30? It depends, how big your family is or whatever. All of that is times 1,000 on an enterprise scale, meaning when you go to a large company like a Microsoft or a Facebook or whatever, you can go to facebook.com and scan them and you might find a vulnerability, whatever, but you're only looking at one thing, one server, right? And now they might have it clustered and all this other stuff, but you're looking at one thing. They might have 10,000 devices behind that you don't even ever see that are internal. The reason this is so important is because attacks on systems almost always they could have been prevented, and people don't realize that you get the comments a lot of like, how could a company that size be dumb enough to not patch their systems? Well, we're going to discuss that because that is very real, and it's not a dumb company or a dumb person, or there is real legitimate reasons why you don't patch certain things, and we'll talk about that. So can a breach of just a single system lead to a disastrous consequence? Yes, of course it can, right? Okay, so now we're on task 3. In most serious attacks, the first goal is to gain access, right? They say in most serious attacks, realistically, that's the only thing to do. Yes, there's other things you could do, but like if you're going to do any attack, and they say serious, but of any caliber, of any value, you got to get access, right? Because like you could do an attack that just gives me a file, right? I don't need to gain access to something or whatever. Just let's just say like a LFI where I can pull a file. Okay, I didn't need to gain access initially or whatever. The initial step was just pulling the file. That's fine, but that's not really that significant. What they're talking about is like large scale attacks. That's what they're talking about. So just think of it that way. Think of what they're talking about here in large scale. You need to grab access because once you have access, you can start moving around, right? And that's what they're talking about. Let's say you have 10,000 assets. If I'm going to ransomware you, I'm not going to go, I got access to one machine, ransomware. You either pay me or I'd never give this machine back, because most companies would say, keep the machine. I don't really care. But if you have 10,000, now we're talking, right? So it's no surprise that users are often those who start. It's no surprise that system users are often those who start the attack. System users are just people that use the systems. Think of it that way, just regular everyday people. By inserting malicious USB found on the street, downloading malware from pirated resources, or simply reusing weak passwords, 81% of breaches involve stolen or breached passwords. That's not surprising at all, right? If I steal a password for your for your Try Hack Me account, I bet you probably use that password somewhere else. So what happens is people get breaches because they have, I don't need your work computer that has security tools. What I need is your main computer that maybe you don't have any security on at home, and I breach that. I sell it on the dark web. Someone buys the credential and they just reuse it at your work. And guess what? It works. So that's why it's super easy to use credentials, because people reuse passwords a lot, and people don't use password managers. People have really poor passwords. It's just when people think of cyber students struggle with this a lot. And what it is they think in their head that everyone thinks like them, right? And that's just a young mentality. And hell, I did that when I was young. Like this isn't a diss on young people. Like I get it, right? Like the world is small at that point, right? But what the biggest thing to understand is there are a ton of people out there that didn't grow up with the internet, right? There's a ton of, I didn't grow up with the internet, and I'm not super old, right? And so understand that there are people out there that didn't grow up with the internet, don't understand it the way you do. And so the biggest thing is, right, is understand in a company of any size, let's say even 200 employees, which is a very small company. Let's say 1,000 employees, right? Even a company that small, the chance of someone working there that has poor practices is pretty good. And so what that means is, if I can just compromise that person's account, I now have access into your company, and now I can spread around. So that's why it's so easy to get access first, right? Once you're in, now we look for vulnerabilities. This is where people get confused, because people say, well, I scanned Facebook, they don't have any vulnerabilities. Bet you if you go look at Facebook's vulnerability assessment, if they, for their internal resources, they have thousands of vulnerabilities inside their company. I guarantee it, because not everything can be patched immediately. So understand that once you get access inside, now you can start really taking advantage of those vulnerabilities. So what is a vulnerability? It's a piece of software. Every piece of software can have a vulnerability or a security flaw. Software vulnerabilities were published, and more than 300 were actively exploited in major attacks, blah, blah. Basically, it's a flaw in the system, right? So, hey, I came out with this whatever app. There's a flaw in it that allows you to get remote code execution, or there's a SQL injection in it, right? That's a flaw. Understand that their flaw is in the system. It's not how it was configured. That's what they're saying here. They're saying it's not like you accidentally didn't check the box that says keep it private or whatever. There was a flaw in the system. That's what they're talking about. Now, supply chain attacks, this is different. Supply chain, you guys may have heard of this with the NPM attack, but basically, or libraries, but basically, think of it this way. Your PC is home to hundreds of apps, including web browsers, messengers, development, entertaining software. Most cybersecurity people run all kinds of stuff from GitHub, and they have Docker containers, and they have all this stuff, right? Understand that relies on thousands of libraries, right? So for instance, let's say I download a library, PyCharm or something like, well, that's an IDE, but let's just say I download any library. It doesn't really matter what it is. And a good example is Obsidian. People talk about Obsidian all the time, how great it is, and how there's public extensions, right? There's public add-ons that you can download, and Templater is one of my favorite. Let's say the owner of Templater gets hacked, okay? Let's say he gets hacked tomorrow. He pushes an update to Templater that is malicious, that runs code on your machine. Guess what? That goes to everybody that has it. That's a supply chain attack, right? You use their supply, and you're in their supply chain, and they push the update, and it goes to everybody. Understand the risk there, right? Think of that on steroids for companies, because an example is SailPoint or SolarWinds or ServiceNow, any of these things, right? These big companies that use, for IT. If they get breached, they can breach every company that company works with, right? ChatGPT, if they get breached internally, that person has access to the whole world, right? So understand the supply chain attacks are very dangerous, and they're getting on the uprise even more. So what is the term for a security flaw that can be exploited by a breach, exploited to breach a system? That's a vulnerability. What is the name of the attack when malware comes from a trusted library? That's a supply chain. And keep in mind, trusted app or library is a in quotes there, because there's a lot of times these supply chains, it's not a trusted library. It's an open source library that they say is open source and and the person themselves just trusted it. Nobody was like, this is a great library to work with. Sometimes supply chain attacks happen even when the library is like not trusted. Like it's like, hey, maybe don't use this library, and people still do it. You'd be surprised. The other thing is with AI, understand AI actually recommends malicious libraries at times. So stop using AI for everything. Make sure you're using AI as a tool, as a guide, as help, etc. But validate and verify everything, because I'm telling you, it's caused a lot of problems. It's good for me because cybersecurity just keeps going up. Like it's not going to go anywhere anytime soon. But so software vulnerabilities, right? So these are the CVEs that you see. You probably have heard of CVE, critical vulnerability and exposure, but you haven't, or common vulnerability exposure, excuse me. But you can see from the moment that CVE gets published, it's a race. Attackers now have the vulnerability. It's been published, so it's literally out there. Here's what the problem is. Attackers, if they don't already have an exploit for it, they're creating them and they're starting to push them out really fast. Defenders need to update their system if there's a patch. Sometimes CVEs come out and there's no patch for it yet. That's where it gets sketchy, right? But they release it because you have to give defenders time to start developing their defenses against it. Because if there's no patch, Log4j is a good example, right? Or Print Nightmare is a good example, right? There was no patch initially. When I say initially, I'm talking like day one, right? When this came out. Well, the print spooler service, you could disable it and that would that would stop the vulnerability. So companies all over the world, when there's no patch, they're like, disable the service, right? And they push that out. That is still a way to fix a system. So when they say, how do you respond to a vulnerability on your system? And the answer is patch. That is not always accurate. Yes, patching is a major point, but it's not always perfect. So what is the CVE for critical SharePoint vulnerability? So basically, the way CVEs work, someone finds a new vulnerability, they submit it for a CVE, it gets published with all the details, and you get the details of that CVE, and from that moment, it warns everybody, this is out there, fix it, and then patches come out. Now you can see, all you gotta do is Google this, and it's 2025-53770, and that's the CVE number. But one thing I'll tell you guys is, this is where you get into students. This is where you get into the conversation of why is cybersecurity not an entry-level position? And it's because this is where you start to see that experience take off compared to a student who just has knowledge. And that's because a student will come in, and this is not a diss on any student. And I'm using student not just as like a college student, just somebody learning the trade, not necessarily a college student. So understand, they'll come in, they'll look at day one and they'll go, you have 500 vulnerabilities, let's start fixing them now, right? What they don't understand is there's a reason those probably exist. There's a reason, right? An example would be, I've done consulting for companies where they couldn't patch a critical system. And you go ask them, why can't you patch it? And they're like, it has to have zero downtime. It cannot go down. If it goes down, something critical happens. Okay, got it. You cannot patch the system for whatever reason. Okay, so what do? Do we say, well, you're screwed? No, you build security around the system, right? And you let that system run and you build security around it. Understand that is a experienced way of thinking. It is not. So start thinking that way, right? Don't think it's missing a patch, you're screwed. Don't think you guys are idiots for not patching systems. There are business reasons and enterprise reasons that you can't patch systems. Availability is one of them, right? What if a patch actually breaks a critical application, right? That's another one, right? That's why they don't patch it and they work on it in QA or something, and they try and figure it out, and then they'll patch it once they fix it. Understand those things exist, and that's okay. Any company of size is going to run into these issues, and the biggest thing is to have a good vulnerability management system in place, a good vulnerability management program that understands those risks, signs those SLAs, puts things in the risk registries, agrees to all the risk, blah, blah, and finds workarounds and solutions. That is the best way to do it. Please do not just think that if something's not patched, those people are dumb, or those people don't know what they're doing, or that they're automatically going to be hacked or whatever. There is always an alternative solution to patching. You can find solutions, you can fix it. You can even fix things without applying the patch and still fix the vulnerability, because patches usually don't just fix one vulnerability. They do multiple things. So if the patch is breaking something, but the fix isn't, you can still fix that vulnerability. So that's a long rant, but it is something to consider, because I see this a lot with experience versus non-experience. Experienced people, they don't go, you're not patching that system, what are you doing? Fix it. They say, you didn't patch that system, can you explain to me why? And then when they go, I see why you didn't patch it, that makes sense. Okay, let me see if I can find a workaround, a security that works with what we need as a security personnel, and with something that works for you guys that doesn't break your system. Let me figure that out. That's an experienced person versus a non-experienced person. So if you want to add value to companies, that's the mentality and the mindset to have. All right, misconfigurations. On the other hand, a misconfiguration isn't a bug, right? This is someone made a mistake, right? So these errors happen frequently, usually to make things simpler, like using 1111 instead of typing a long password every time. So real world examples: 1, 2, 3, 4, 5, 6 password exposed chats for 64 million McDonald's job applications. So they use this password basically because they didn't want to have to like put it in a vault or whatever, and it exposed chats for 64 million job applications. Might sound like nothing, but that could expose a lot of information about people. Misconfigured AWS cloud resulted in breach of 106 million bank customers. Okay, that's a lot, right? Improperly configured smart fridges are silently used in full-scale botnets. So this is something, these didn't have problems with the system. The system was built right. It was secure. The person who configured it never configured it securely. An example is Linux, right? Red Hat Linux, their entire shtick of their flavor of Linux is that it's secure Linux, right? SEL, secure Linux, right? So if they're using secure Linux and you're using Linux, what do you think's the difference there? It's just the configurations they put. Both can be equally secure if you do things correctly. They're saying, we'll do all that hard work for you. You just got to pay for it. So understand that misconfigurations are normal. They happen, and it is what it is, right? So here's kind of the setup, right? Install the latest SQL database, put customer database in the database in the data, or sorry, data in the database, excuse me. The database now has sensitive data. Set the password to 111. There's your misconfiguration, right? All the other things were fine, but you set the password, and then here, disable the firewall. I don't know why they would have done that, but you can see the misconfiguration exists in where the user interacted and made a mistake during implementation. I will tell you, this is a trick that I don't tell a lot of people. I can't remember who taught this to me, but I started doing this, and it's changed a ton of my consulting. Go through, let's say someone implements something, right? If you find a company, you do some recon, and you find they implemented something recently. Go through the documents of what they implemented and find where it starts getting really difficult, where it's like, okay, what? Hold on. Let me go back through. You're rereading. When you find that point, you find most misconfigurations, because a lot of admins are pushed to timelines, and they're like, I don't know. I just got to get this thing out there. And so when it gets really hard, they just do what they have to make it work. And that's where misconfigurations happen. So start thinking that way when you're looking for misconfigurations. Can a system patch or software update fix misconfigurations? They say no here. It technically can. This is a nuanced thing, but there are patches out there or updates to systems that will disable legacy security issues. So it is possible. I'm not saying normal, but possible. Which activity involves an authorized cyber attack to detect misconfigurations? That's penetration testing. Most of you probably already are familiar with that. Okay, so our job here is to do systems at risk. Okay, I can't do, let me reset this thing. There we go. System at risk. Okay, the penetration team reported that Exchange mail server is affected by this CVE. So we did a scan. There's a CVE affected. Okay, they managed to breach the server thanks to the CVE and said anyone can do it since it's internet exposed. So what should you do? So this is where you get into nuance. We don't have enough context here. We're just going to say apply or ask IT to apply the patches and update. That's fine. But what you really should do is probably restrict and not this. There's going to be some controversy this, but there's only 3 options here. So I'm just saying that like you should restrict the issue until it can be patched. If the patch is going to be delayed, if you can patch it right now, patch it right now. If you can't, you need to set up some security around it while you're in the meantime. Okay, the threat actors managed to brute force an admin panel of our WordPress site, replace the main page with malware and gambling. What action should be taken? Well, you should restore it from backups, but not close the alert. Update the website to all the latest version. That wouldn't fix it because they brute forced, meaning they did the login. So you need to change all the passwords for the admins. Okay, our neighbor company was hit with ransomware a week ago. They say it started from an exploit of the old Cisco firewall and advised us not to repeat their mistakes. There's something here that you guys might not consider, but something that I think is extremely important for anyone watching this video. Please do this. if you ever get hit with something and you have a company that you work with all the time, you have a company that you know that you are close to physically, anything, please tell everybody you can things to watch out for, how to fix things, put it in threat advisories, do whatever you can to get that information out, because the more you share on defense, the more likely other companies are to not get hit with the same thing, and share and reciprocate that, right? Call your local authorities, have them share it, disseminate it, whatever you got to do. Please help each other out. It will help you tremendously. So what should you do? You do want to ensure all corporate firewalls are patched and do not have CVEs. Replace all Cisco devices. Disable all firewalls. Disabling all firewalls doesn't really make any sense. Replace all Cisco devices, again, doesn't make sense because as of right now, you can see it started with the exploitation of their old Cisco firewall. So it may not be the Cisco issue. It may be a misconfiguration or just an old legacy system that they didn't patch. So you're going to apply patches. One thing to keep in mind too, certain legacy systems do not have patching if it's that outdated. So understand, if it's super outdated, that might be your problem right there. So if there's not a patch being applied, you might say, oh, this, for instance, 2000, Windows Server 2008, you can't get patches for it anymore, right? So you observe an unusual spike of security events coming from the designer's laptop. A trusted 3D design application suddenly starts running malicious commands. That's automatically a supply chain, right? If a trusted application starts doing really funky stuff, unless there's an exploit or a vulnerability and someone is taking advantage of it already inside your network, the likelihood, especially if it just got updated, is that it's a supply chain attack. All right, there you go. Try hack me, patch, or reconfigure. Now we go here and we do the remediation plan. So they're saying, hey, you got to select 4 things to remediate. So first thing, block public access to your company's website. Doesn't make sense because you would actually be stopping business. If you have a company website and you just blocked everyone from going to it, that doesn't help. You need antivirus. You need a patch management policy. And you notice it says define a clear process for identifying, testing, and applying patches. You need security training always. And then secure password policy, right? You have to have secure passwords. Shared accounts, never use shared accounts. Doesn't matter why, never use them. Obscure naming, use random server names like blah, blah to confuse potential attackers. Doesn't really confuse anybody. I will say it makes it harder, I guess, theoretically, because I have to guess what that server is. But I can look at a server and look at the services and very quickly probably tell you what that server is. The other problem with that is that also confuses the enterprise. That might sound silly, but you get a new person coming in. Now they have to learn this whole weird naming convention and all that stuff. Just name the servers what they are and hopefully, secure your stuff and you won't have as much to worry about. But that's neither here nor there. So let's go ahead and approve them. There you go. We got Try Hack Me Best Systems Defender. So there's your 2. And that's it, guys. This is the systems as attack vector. Okay. I don't know what just happened. Guess we're done with that. But that is systems as an attack vector. Hopefully you guys learned something. Hopefully this helps you guys, and hope you guys have a great day.